Today we're going to be talking about piecewise functions, and that's a function that's defined in different ways for different parts of the domain. So you can see here we have an example of a piecewise function where we have three different functions that are defined on different parts of the domain. So this first function is a linear function, and it exists from where x values are less than -2. This function, a squaring function, which will be a parabola, is defined from -2 to +2 in terms of x values. And then this function, -1, which is a constant function, is defined for x values that are bigger than 2. So when it comes to graphing a piecewise function, there are two different ways to do it, and I'm going to show you both ways so you can decide which way works best for you. Okay, so one way to do it is to just sketch both functions. Alright, so the first function I pointed out was a linear function. If you take a look at the equation, this is the y-intercept, this is the slope. So you can sketch, and I would say lightly sketch, so I'm going to sketch mine in light gray. So the y-intercept is up at 4, that's up here, and the slope is 1/2. So we go over 1 and up 2. And I can go back and go over 1 and down 2. And I'm going to roughly sketch this. Okay. The next function is my quadratic, my squaring function, and it's the parent function but shifted down 1. This -1 at the end shifts it down 1. So it will have a vertex here. From there we go over 1 and up 1 in both directions, and in both directions we go over 2 and up 1, 2, 3, 4. If you guys remember that from when we were talking about these parent functions. Okay, so I'll roughly sketch that. It's not the most beautiful, but we'll go with it. Okay, and technically it has arrows at the end because it is going on forever. Okay, and then -1, that's our constant function. That means that it's always at y equals -1. Okay, but we mentioned that this piecewise function is only defined for parts of the domain. So the first thing, the first equation was a line, and that's only defined for x values less than -2. So here is x equals -2. Okay, so we want to go to the line at -2 and put an open point there because it says less than -2, and darken this part of the line and say this is going on forever from there. So this here is the function that's defined for x values less than -2. Alright, now the parabola, oops, I did less than -1. Okay, let's see if I can get rid of that. Okay, here we go. Less than -2. So that would be here. So we highlight that. Okay, there we go. Alright, so the parabola is from -2 to +2. So I start on the parabola and I go from x equals -2, which is here, and notice it has an or equal to sign on the inequality for -2. So that means that we're going to draw a closed point there and highlight all of this, the whole parabola, until I get to x equals 2. I'm at x equals 1, now I'm at x equals 2, and I'm going to put a closed point there as well because I had an or equal to on this side of the inequality. So if I have a not or equal to, if I have less than or greater than, I'm going to use an open point. And if I have an inequality that is less than or equal to or greater than or equal to, I'll put a closed point on my graph. Alright, this last chunk I'm going to highlight is -1, the constant function for x values greater than 2. So we go to x equals 2, that's here. I put an open point there and I highlight my graph. In the case of you doing this by hand with your pencil, you won't be highlighting it, but you'll be darkening it, and then you can kind of erase what you had drawn before. So here's kind of my finished product doing the piecewise function this way. Okay, so then the next thing that I'm going to show you guys is how to do it without sketching each piece. So we're working with the same piecewise function, and what I just did was I graphed it by sketching the entire graphs and then kind of darkening the needed parts and erasing the unneeded parts. So I'm going to show you another way that you can do this, and you can kind of choose which way works best for you. Alright, so for this first function, this was our linear function, and it exists for x values less than -2. Okay, so basically I only care about -2 and lower. And even though the inequality says x is less than -2, I still need to draw that point on my graph, okay? It's just going to be an open point. So I'll put a little symbol next to this. Oops. I'll put a little symbol next to this indicating you're going to draw an open point as the endpoint. Alright, so we care about plugging in -2 into this function for x. Okay, so if we plug in -2, we get 1/2 times -2 plus 4. Okay, so we plug -2 in for the x value. 1/2 of -2 is -1, plus 4 is 3. Okay, so that's kind of what I call my cutoff point for this function. So at x equals -2, I have an open point up at the y value of 3. So I go up 1, 2, 3, and I draw an open point. Okay, and from there maybe I can plug in a couple other points. Since this is a line, I really only need to plug in one more point to keep sketching this. So maybe let's say I plug in, let's not plug in 3 since that's not going to give us a whole number since we're doing 1/2 of it. So let's plug in -4. So 1/2 of -4 is -2, plus 4 is +2. So I have a point at -4, +2. Okay, and you could keep going if you wanted to. This is a closed point. Alright, so we can draw this line that's going on forever in the negative direction because this inequality here told us that x values were less than -2. Alright, let's look at the next piece of this piecewise function. This squaring function is the case from -2 to 2. Okay, so we can take a look at our cutoff points, and our cutoff points here are both -2 and +2. So those are definitely important points to graph on here. So we want to plug in -2 into x squared minus 1. So -2 squared is +4, minus 1 is 3. So I have a closed point up at 3 for the x value of -2. Alright, let's plug in 2. So 2 squared is 4, minus 1 is also 3. So at x equals 2, I go up to +3, and I've got a point there, and it's a closed point because we had an or equal to. Okay, so next I need to fill in between these. So if you have an idea of the fact that this is a quadratic function shifted down 1, you can sort of just sketch it, or you can plug in points in between -2 and +2. So maybe you might want to do that. So let's plug in -1. -1 squared, we're plugging in here, we're plugging in -1. So -1 squared is 1, minus 1 is 0. Alright, so at -1 we're at 0, and that means at +1 we'll also be at 0. Okay, and let's plug in 0. 0 squared minus 1, and you got -1. Alright, and we can connect those points now. I switched to a bolder line. Alright, now I'm on the home stretch. I just need to do this, the constant function, this piece, which is the case for x is greater than 2. So basically, you're looking at the cutoff. You really always care about the cutoff. You need to look at those cutoff points. If we plug in 2 into this function, does that do anything? There's nowhere to plug into, right? So really, I just need to go over to x equals 2, 1, 2, and go down to -1. And do I want an open point there or a closed point there? So So in an open point there, since the inequality up here says x is greater than 2. And then that goes on forever to the right because it's for all x values greater than 2.